Thank you for joining, everybody. I prepared for you a couple of slides, but don't worry, we will be looking at the Marimo notebooks in the demo shortly. But just to give you a quick overview of what I would like to talk about and what you can expect into the presentation, like the live presentation, the live demo. Right. So, as you can see, Marimo claims to be next generation Python notebooks. So I've taken liberty and created the presentation inside Marimo itself. So let's get into the next slide. Our agenda is pretty short. Introduction, comparison with Jupyter, demo, that would be longest, and conclusion. So let's go with a bit of marketing pitch. I don't know if you can see, yeah, because it's refreshing with a bit of delay on my side. So on the preview, right. Um, So let's go over some pain points that you may have inside Jupyter Labs or Jupyter Notebooks or Google Colab or anything else that Jupyter is deployed right now. So did you try to merge Jupyter Notebooks and had a conflict with different branches? I have. I didn't like it. And I think when you did it too, it also caused you a lot of pain. Maybe you had a presentation to run and you couldn't reproduce the results that you found out and reported over Slack because the cell order was different, and actually the thing that you reported were mistake of different cell being executed in different order rather than the correct one from top to bottom. Yep, also happened to me. Or maybe you have a specific instruction how to run the notebook because don't move these cells, don't move them because it would break and you need to execute them a specific order, right? We've been there too. Um, when you try to visualize data in Jupyter, you'd maybe created some plots and wanted to see some data with different angle, different filter. Yeah, another bunch of throwaway code that is only used for filtering a small amount of data, then again and again and again, and you have huge notebook just for filtering data and doing the same thing at a bit different angles. Or yeah, maybe you did pretty nice plots that you wanted to share, but you could only share them as notebook into the slides, from the notebooks to slides as an image. Well, in that case, all of your interactivity from Plotly, for example, was gone, and you couldn't zoom and show what you really wanted to show for your stakeholders. Yeah, also a problem, right? So I have a solution for you. It's called Marimo. Let's go talk about Marimo. So let's move forward with the slides. Right. So basically, to get you understanding what Marimo actually is. So Marimo is just like a Jupyter a tool for building notebooks. But differently from Jupyter, Marimo is reactive. That means every cell reacts to user interaction, and they depend on each other non-linearly. So basically, Marimo constructs a graph of the execution that puts some constraints of what you can do inside Marimo, but also is better from perspective of software engineering. And as all here gathered, we are data scientists, software engineers, machine learning engineers. I believe all of you like clean code, and maybe like the ugliness of ad hoc code causes you pain. Then Marimo actually is a bit tidier than Jupyter because it enforces this tidiness. But again, in this case, Jupyter is a bit more freeform, right? You can write whatever you want. You don't need to worry about that much things. Just type away and be done with the results. So these are two different models of execution and of the mindset. Um, so basically, in Marimo, the execution is always guaranteed by Marimo to be in exact order. What exact means I will show you in the live presentation. Uh, inside Jupyter, well, it's more imperative. You can select cells that you want to run. They don't need to be. They don't connect it. They do not connect to each other, like logically. They are basically a bunch of Python code that you can execute and dump the variables into some global memory state. Or you can execute from top to bottom, but you don't have this logic behind this. What's depend on what? Um, why I said about the merge conflicts being painful in Jupyter, because at the end of the day, Jupyter is just JSON file, like huge JSON file that is hard to merge because it contains all of the metadata, cell outputs, and also stuff like the Python code being stringified version of a JSON body, which is, well, first ugly, second it's like extremely hard to merge because small changes causes lots of divs to be generated. So it's pretty hard to do. Inside Marimo, every notebook in Marimo is basically a Python file under the hood that gives you nice features. One of them is being that, well, you can merge them easily because you basically what you see inside the notebook is basically one-to-one what you see in the back file that is behind this notebook that stores it. But also you can run this as Python scripts directly. Also, you can deploy that as a web app, which is also a nice feature of Marimo. Um, and let's go to the demo, right? So as you can see, we are already inside Marimo, inside the slides notebook. And right, I'm showing you slides, but actually the slides are this a Jupyter notebook, Marimo notebook, pardon me, that is mix of Markdown and some Python code. For example, here I'm building the slides as Marimo UI components to make them pretty. But yeah, basically, this presentation was whole Marimo. So let's go over the basics. Um, all you need to know about Marimo, if you understand this principle that Marimo is reactive and execution is guaranteed by directed acyclic graph, then you can basically do whatever you want with Marimo. It has lots of limits compared to Jupyter, but it's for your benefit. So let's go over this quickly. Here we have simple cell that defines A equals to 12. Here we have cell that defines B equals to 2 and X is a half, right? So let's run them. They are actually run, so nothing changes. But let's say I want to update A, for example, to 10 and run this cell. Did you notice? I run A cell, but also B was rerun, and then A is equals to 10 because I updated this cell, and this cell needed to be updated as well. That's the reactivity. Also, if I move this cell after this one and also change this, let's say maybe to 5, around this, again, this cell was updated because it depends on this cell, right? You can think about the cells differently than cells in the Jupyter. Jupyter is basically a bunch of code that you can execute, and that's it. In Marimo, cells either depend on some state and define some state, and they compute something over the state. So this is a state machine, basically. And I can show you how the state machine looks like, actually. If you go to the explore the dependencies, we can display basically inside Marimo what cell do we have defined and what cell depend on what other cells. So here we can see that our cell 2, this one, depends on this cell that defines A, which makes sense because we are using A here. And how it's working under the hood, if we open this file, I meant to open this as a file, not as a notebook, right? This is under the hood what this notebook looks like. Basically, it's a bunch of unnamed functions that are decorated with app cell. And then we can see that our cell, this one, that defines A, is basically a cell that doesn't have any dependencies. It's a function that returns a state, but doesn't accept anything. And this cell, right, this one, it accepts state A and returns B and X because we are defining them. For this reason also, you need to be aware that if I want to create a, let's say, oh, I want A to actually be called 10. Oh, I cannot. I would be able to do that in Jupyter, but in Marimo, it's impossible because now two cells define the same state, A. So which one is the correct one? We don't know, so we cannot define that. That may be a problem for the beginners that's working with Marimo, but it prevents you from doing some hidden state that you mismatch the inputs of your cells, and maybe you have some data frame, then replace the data frame with something else. Then it's no longer would be working with the cell that you defined before. And now you may, maybe have some not idempotent operations that basically accumulate errors. So yeah, this entirely prevents that. Okay, but what you see here is like some inputs. I can put it up and down. We have sliders. Okay, so let's use them. Uh, Nice thing is that it is restrictive that you cannot define the same variable between the cells, but you can still modify them just fine inside the cells. This is because, as you already saw, the cell is basically a function. So the context within the function is local. You can rename the variable, redefine the variables there just fine. Just outside the cells, if you want to use it, you need to be aware that you cannot modify it. So let's say that B is dependent on this input, our slider, and the same A is dependent on our number input. So now let's see. Again, let's move this cell. I can do that just fine because it's reactive, so it won't be bothered that it's in different place. If I modify it, I can see that the variables are changing. The UI is updating by dragging and dropping. And the same goes if I, for example, do define the same input here, because I'm displaying the same stuff, and I can have dynamic plots that I can modify on the go as I'm showing you, right? So I can drag and drop. The plot is updating dynamically. Also, the markdown cells are updating dynamically because I can inject Python directly into the markdown. Okay, that's basics for you. So that's pretty great. I think you can get the understanding what we can do with it. But let's now talk about Lego, right? Lego. Everybody, I think, played with Lego at some point. I think everyone likes them, or at least the notion of building stuff. So let's do some analysis on the dataset that I pulled from Kaggle about Lego and the sets names, the sizes of the amount of pieces and stuff like that. So Marimo integrates really great with polars. Of course, it integrates great with pandas, but as Marimo is more new kid in the block, let's say, it's like more new tech stacks. So basically, it really is really great with polars, with DuckDB, and also with package manager, like like UV. I can install anything with UV here because I have a UV project under the hood. And also, one last thing that I wanted to show you in the basic that I forget before. Like I said, you can execute these scripts, these notebooks as Python code. So if I go UV run basic spy, right, and run this, I get the values printed. Well, that's because the only thing that this script's output, this code outputs actually like as a Python is print, but it could be, well, some file input output. I can even pass variables as arguments to the scripts and modify them in UI like this, but also pass them from the script and have application ready to be a command line application on the go already. I won't be going into these details because this is already lots of things to cover. So let's go over nice features for data analysis and also for data engineers. But again, probably for everybody here at our company. Right. So what I prepared for you here is some day slider and data set for the Lego sets, like I said, and we can explore it, display it. So again, nice feature. We have this. I can make it close it. We have this data set that is displayed here, a Polars data set. And let's say, oh, I maybe want to have only the sets from 2005 above, right? It's already updated. Like, you don't need to rerun this. It's rerun for you. You can display it. So, oh, and what's this? I see the images directly inside my data frame that is displaying, because Marimo already gives you the preview of the URLs that are PNG, a JPEG, and stuff like that. So if there's image URL, it will pull for you, so you can easily display it here, which is really nice feature. Okay, but that's all and good, but maybe I want to drill a bit down. So we have technique Lego. Maybe let's filter. And so I could actually filter it right here. So let's say I want to have a city. So as you can see, I can directly use the display data frame to filter it down. I can also see the properties of this thing. So let's say I can go column explorer and see, for example, the number of parts, and I can see the distribution of the features there. For example, number of parts filtered in the city theme Lego only, right? Which is really impressive. Let's try to code that inside the Jupyter. But we can also do more. Sometimes it's much easier to write these things, these operations, as a SQL statement or SQL statement, depending on English that you are using. But let's say it's SQL statements. So here we have a nice example of grouping, having, and order by, right? Because maybe it's much easier for you to write in SQL, that's fine. But see, we are using directly the data frame as a source that we defined here. So we loaded Polar's data frame. We use this Polar data frame inside the SQL statement, thanks to DuckDB, because right now this is like unified backend, but with PyArrow. So there's zero copy actually going on under the hood. It's directly using the same binary buffers, so it's also performant, which is also nice to have. Okay, but right, we have this, and maybe we would like to visualize that for our stakeholders. So we can start typing the charts, of course, but I can also click here on the chart builder, and like add a new chart. So let's say I want to have a pie chart, and I want to have pie chart by the theme name, and I want it to be by average number of pairs. Well, I have already a nice chart, but it's a bit cluttered, so there's too many things going on. But well, we still have SQL that is already ordered, so maybe let's go and limit that by 10 and run this. And our chart updated automatically, just like that. And yeah, this is great. Maybe we want to modify that later forward, so we can get the Python script for this chart in Altair. So the plotting library for the Marimo is Altair. You can also use Plotly and Matplotlib, but the Altair is like this, the default, I would say. And I will later show you why. But yeah, but you can just plot your data directly here without any code needed. So it's much easier and faster if you want to do some ad hoc analysis like that. Uh, so yeah, that's great. And here also the same plots basically. But that one was generated by an AI. Well, of course, keyword, but you can just go generate with an AI, say what you want, include the data frames that you want to be included in the context, and you can select what provider do you want. I'm using OpenRouter and Grok Code Fast for this. And yeah, you can just type away and ask the AI to generate code for you directly inside the notebooks. And that's not all. You can have code completion with AI, but you need to integrate with some GitHub compiler or something like that. So I didn't bother with that, but you have an option for that right here. Right. So as you can see, I have even some chats past. So you can configure just inside this, use something else. That's pretty nice. The other thing is when we are at the data frames, we are using the Polars data frame that I'm loading, well, from the memory or actually from the disk. But maybe I want to connect to something else. And there's pretty much lots of data sources for you. Well, actually anything that the SQL Alchemy supports, this stuff like you see ClickHouse, Data Fusion, Databricks, Redshift. So you have whole plethora of connector that you can use if you want to analyze the data from external servers here. So go for it. You have lots of options. Okay, moving forward. I also got and analyze a bit of MNIST dataset, right? To show you something, some interesting examples. First thing that you can notice here, this is Fashion-MNIST. So first thing you can notice, we are using cache. So this is the downside of Marimo and the strength that is reactive. But you need to keep in mind that this is completely different model. Jupyter is much easier for like beginners because you can run your cell. Once it's run, everything is saved. In Marimo, you can run the cell, but everything that depends on the cell also would rerun. So if you change something that has heavy computation, yeah, you may actually get pretty nasty surprise by generating or calling really costly APIs or like costly computations. It can be, cost us money, but also time and memory. Lots of things, mostly time, I would say. So you can cache these values. You can cache them like in memory, like I do. You can cache them to disk with Marimo also. But this is something that you need to be aware of, and this is completely different mental model that you need to have in your mind. So Marimo up to this point is great, but you need to keep in mind that this this comes at a cost. That you need to have a bit more, a bit more knowledgeable about the software that you're writing. Right. So we have a Fashion-MNIST dataset, and here I have nice UI elements with dropdown, filter, and carousel. So let's say I can see sample data from this fashion dataset, right? But okay, maybe I want to see particular class, so like maybe dresses. I can just do, exactly that. Or maybe I want to see, I don't know, shirts, right? You get the idea. I have drop downs directly here. I can use it. And also this, maybe you don't like this view that you have this code here. Maybe you wanted to present this application to your stakeholder as a web app. You can do that. And if you would deploy that as a web app, either HTML page or HTML with WebAssembly, because this is also supported in Marimo, you can also I would click Control dot, but you can also go here and present as a view, right? So now everything regarding the code is gone. Try achieving that with Jupyter with the standard one. That's here in out of the box. So you have basically an app to explore this data set, right? That's much more clean, much easier to show, and also to for you to work with this data. And let's see here. So I have embeddings, Disney embeddings actually. So pretty boring, but um, why it is important? First, because I can use cache to cache the embeddings, right? That's the important thing. You can see it here that I'm caching these embeddings on cache, complete embeddings here, right? And outputting this as polar data frame. But I see all of the things, all of the items here in this space, right? Pages, I can create how much I want to see, but I can display them. But maybe I want to go further. Maybe let's see why our classifier is not the best. Maybe it has some missing in the embedding space. So here's our couple of classes. I selected this area in the chart, in the notebook, and it already filtered me the data that is directly in these points in this embedding space. And I can see why, for example, they may be confused they close because this pullover is similar to the code inside of pixel density, same the shirt, of course, again, this is TC embedding, so don't draw any conclusion from it if they are close to each other because it is simple pixel pixel values. But if you have like words embeddings or anything like that, yeah, you can easily display what's common on the space of your plot in this embedding space and see what's happening under the hood. So yeah, again, and maybe and of course, I don't know if you are used Power BI, maybe not, but or like any Tableau or anything like that. But let's say I want to see only t-shirts. I can select that and it also filters only t-shirts. Or maybe I want to have t-shirts and sneakers. With shift I can click and like that. That's the missing link in the presentation that you want to show to external people. Like, oh, the problem is with our data because if you zoom here, I can just drag and drop. You can see this is pretty similar items here, right? So that's the problem. This is the problem of our embedding space. So yeah, like these tools actually gives you the ability to show these things to external people much more easier than what we had before. And I also want to show you other thing, the last thing in this presentation. So I did a bit of goofy thing to um, improve my images to be LinkedIn ready or presentation ready. So if you want to have a profile pic, just hit me up. I can show you how to do that in Marimo or just stay tuned here. But I'm using Nano Banana with async client. And async and notebooks don't get along pretty well because, this is different computation model. But in Marimo, you can just await and that's it. It works. And also you want to maybe have a spinner that shows you the progress that it's working in the background. Yeah, so you can just do the spinner here. And that's also fine. That also works. So I can show you if I upload a file with myself again. So I have prepared that picture also. So I uploaded the picture. It is processing in the background, and we will see in a minute when it would be replaced. Right. So totally not me. I like the chisel jaw, by the way, that it gave me. Maybe I need to have some surgery then, but maybe that will be me in the future. But aside from that, yeah, you can have async code inside your notebooks too. And yeah, going back to the slides, demo time is done, and the final conclusion that I can draw to you, but also you should have all, but based on my presentation, your thoughts already, if you would like to use it or not. And I would say go ahead and try it. It's pretty new thing. It's not that it's well supported outside, like local. There's like I think one cloud vendor already is trying to, but not known cloud vendors try to produce to have that working in the cloud. So use it locally. That's great. If you want to have integration with, I don't know, like Google Collaboratory level stuff, yeah, I wouldn't say that's that much yet. And also maybe there is some friction inside the teams you are working, like our external teams, that basically they already have lots of Jupyter Notebook and they are comfortable with Jupyter Notebook. Basically, maybe they have great practices working with them, and they don't want to learn a new tool. That's also fine. Like you don't need to use this on your project that you are working on, but I would recommend you try it out for yourself because maybe you will like it as I enjoy working on this presentation for you. And the more and more I explore the Marimo, the more and more I wanted to present. But unfortunately, our time is over. And so thank you for your attention. And